Okay, so earlier in the week, I introduced you to different kind of stuff. I'm gonna start uh, with some examples, just like what I mentioned. You have a set A, you have some numbers listed, and you have set B. And how do we figure how A minus B? Okay, the A minus B is actually talking about um, the the complement of set B in set A. So what are the elements that are actually in A, but they are not in B? So if you compare them, okay, uh, 2 and 4 is right here, and I don't think it's here. Is there any question about this? That's how to do that. Okay, if you are given some, you have a set A and set B, you want to find A minus B. Okay, then you want to find B minus A. What are the elements? Okay, in B, but not in A. Okay, element in B, but not in A. You know, we got a definition. Okay, if I talk about A minus B is S such that X lies in A and X does not lies in B. Okay, this is a mathematical definition of A minus B. And on the other hand, if you want to do B minus A, then you have S such that X does not lies in that and S lies in that. Can you see that? Oh, sorry. And S lies in B. Okay? So, is there anyone who doesn't understand how we figured that out? Now, the moment you understand the complement, the relative complement, this guy is going to be easy. The symmetric, A symmetric B is A minus B union B minus A. And of course, you take a look at the union, right? That's going to be the list of all the elements here and here. You combine, and that will give you that. Any question on that? You're good, right? Okay. So that is how. So if I ask you to find a symmetric B, okay, the symmetric difference, you need to first find the relative complement, then you find the union of the relative complement, then you're going to be fine. Okay, so 1 and 2, the same. I'm talking about the same question. Okay, so in 2 now, I ask you to find the symmetrical difference directly. So I expect that you first find A minus B and B minus A. Okay, and this is a mathematical definition of what I'm actually talking about. Okay, now if you understand that now, if you take a look at question 1 and 2, okay, question 1 and 2, you have numbers, right, in the set. If we take a look at question number 3, okay, we got alphabet, right? We could have anything can be element. It could be numbers, it could be it could be alphabet, it could be color, it could be whatever. Okay, take a look at this guy now. Okay, you want to find that, right? So I expect you to find P minus Q first and Q minus P. Then the union of that will automatically give you that. Is there any question about number 3? Is there any question? Okay. Now I want to go to question number 4 now. Like I said, what we're having today is just to walk you through some examples, mathematical examples. Now take a look at question 4. Okay. Consider the set. Let's come around. You can see what we have. in A, B, and C, right? And find the following. Find A union B, find A intersection B, then find A complement intersection C. Okay? Now, if you want to find A union B, that's going to be super easy. It's just the least of all the elements in both A and B without repetition. There's possibility at times in A, maybe there's a particular, okay, let me see here. Do you see A here and B here? You're actually going to see that I think they have red and red in common, right? Okay, if I want to do the union, I'm not going to write red twice. It's just going to be once. Does that make sense? So, um, so this guy here now, give me 1 second. I needed to take a look at this. Okay, that is the union that I talk about. Okay, you can see I did not write red twice. I only write it once. Red, green, blue. You can see that as a union. If they have any element in common, we're not going to repeat that. Okay. Now the next is the intersection. Of course, the intersection is what A and B has in common. Okay, what A and B has in common. Okay, which is going to be red in this case, and that was why you see that guy to be red. Okay, that's right. So then the next is you want to find you want to find A complement intersection C.